Today, we're going to tackle about graphing a polynomial function. So the technique of finding and plotting as many points as possible is helpful, but there are theorems on zeros of polynomial function that are great help to be able to sketch the graph of the polynomial function, and that is the bound of zeros. So these are the bound of zeros. So the upper bound and the lower bound. This is very helpful in finding the table of values. But before that, let's be mindful in the rules. So upper bound should be x greater than 0, such as positive 1, positive 2, positive 3, and so on. And the entries of the third line is positive. While in lower bound, it should be x less than 0. So negative 1, negative 2, negative 3, and so on. And the entries of the third line is alternating. So it is very important to know how to identify the upper bound and the lower bound, because this will help in creating the table of values. The table of values will give coordinates that will help us sketch the graph easier. We have this function of fx equals 3x cubed minus x squared minus 9x plus 3. So how can we solve the upper bound and lower bound? Always be mindful of the rules. So I will show you how to do it. Let's test all the possible zeros if it will satisfy the rules of the upper bound that the third line should be positive. So let's use synthetic division in finding it. So in synthetic division, we need to write all the coefficient of this equation. So 1, 3, negative 1, negative 9, and positive 3. Bring down this first coefficient. And then 3 times 1 equals 3. Subtract negative 1 plus 3, positive 2. 2 times 1 equals 2. Negative 9 plus 2, negative 7. Negative 7 times 1, negative 7. Negative 7 minus negative 7 is negative 4. As you can see in our answer, the third line is negative. So it means this is not upper bound. So x equals 1 is not upper bound. So let's try to test the x equals 2. So let's test x equals 2. We still need to use synthetic division. So bring down 3, 6, negative 1 plus 6 is 5. 5 times 2, 10. Negative 9 plus 10, positive 1. 1 times 2 equals 2. 3 plus 2 equals 5. So as you can see, our third line is already positive. So it means our upper bound is 2. Our upper bound is 2. After that, let's proceed to the lower bound. So next, let's find the lower bound. Since the rules of the lower bound, x less than 0, so we need to use negative sign. So negative 1, negative 2, and the answer should be alternating. So first, let's test. So let's test x equals negative 1. We still need to use synthetic division. So bring down 3. 3 times negative 1 equals negative 3. Negative 1 plus negative 3 equals negative 4. Negative 4 times negative 1 is positive 4. Negative 9 plus 4 equals negative 5. Negative 5 times negative 1, positive 5, and 3 plus 5 equals 8. So as you can see, they are not alternating because positive, negative, negative, 8. So it means x equals negative 1 is not lower bound. Since x equals negative 1 is not the lower bound, let's test the x equals negative 2. So, we need to bring down 3 and multiply it to the divisor. So, it will lead us to negative 6. Perform the operation and our answer is negative 7. Negative 7 times negative 2 is positive 14. Negative 9 plus 14 is 5. 5 times negative 2, negative 10. 3 plus negative 10, negative 7. So as you can see, it's already alternating. So positive, negative, positive, negative. So it means our lower bound is negative 2. Negative 2. Again, our upper bound is positive 2 and our lower bound is negative 2. To effectively and accurately graph the polynomial function, we need to utilize the table of values by using the upper bound and the lower bound. We need to begin in lower bound up to upper bound. So negative 2, negative 1, 0, 1, positive 2. Since we already have the value of x, which are the negative 2, negative 1, 0, 1, and 2, we're going to substitute this value to the given equation just like this one, and we can get the answer of negative 7. And for the next one, positive 8, 3, negative 4, and positive 5. Again, in getting the values of y, we need to substitute the value of x to the given polynomial function. So this is our values of y. Negative 7, 8, 3, negative 4, and positive 5. So next, we're going to plot the coordinates. So the first coordinate is negative 2 and negative 7. So this one. Next, negative 1 and positive 8. So, negative 1 and 8. Next, 0 and positive 3. 0, positive 3. Next, 1, negative 4. So, 1, negative 4. 1. 2, positive 5. So, 2, positive 5. So, we're going to connect the points of the coordinates. Wait. Let's see. So this is the graph of the polynomial function of fx equals 3x cubed minus x squared minus 9x plus 3. As you can see, there are two turning points. How do we know the number of turning points in the given equation? So this is the formula. Degree of polynomial function minus 1. So in this equation, we can see that the degree of polynomial function is 3. So 3 minus 1 equals 2. So if we're going to compare it to our graph earlier, so turning points 1, 2. So it means that our graphing is correct. So there are behavior of the graph. For the odd degree and the positive leading coefficient, just like this one, fx equals x cubed plus 6 squared minus 3x plus x, the graph will be like this one. The graph falls on the left and the rises on the right. So, fall in the left and rises to the right. For the negative leading coefficient, which is this one, fx equals negative x raised to the power of 5 plus 6x raised to the power of 4 minus x cubed plus 2x squared plus 6x plus 7. So the graph will be, the graph rises on the left and falls on the right. So, rises on the left and falls on the right. So, if there is an odd degree, there is also an even degree. So, if the even degree has positive leading coefficient, just like this one, the graph will rises on both left and right side. So, both right side. Both left and right sides. And if it has negative leading coefficient, just like this one, the graph falls on both left and right sides. So that is the difference between odd degree and even degree. So that's all the discussion about graphing polynomial function. Always remember, if you're going to find the upper bound, it should be x greater than 0, such as positive 1, positive 2, and so on. And the entries of the third line should be positive. When in lower bound, it should be x less than 0, so negative 1, negative 2, negative 3, and so on. And the entries on the third line are alternating signs. Example, positive, negative, positive, negative. So that's all for today. I hope you learned something and see you next time. Once again, I'm Krystaliza and thank you for watching.